So today you should be writing in your front of your table of contents, page 71. Last time, and you might have these two swapped on gluing, and it's okay. I'm not going to count off for that. If you need to draw an arrow and change it, it's fine. But we're going to be solving two-step inequalities, and this is the end of chapter 7. So when you come back from the break, we'll actually be testing over this from your long little break. So we're going to be on lesson 7-7, solving two-step inequalities. This should be on page 71. Okay, and then we'll be folding those notes over and gluing those in. So I don't go through those steps and motions. Hopefully you are when you're getting done. So here is our lesson for today. And with one-step inequalities, like always, we talk about PEMDAS as being order of operations, but when we solve equations, we do it backwards. So instead of doing this, we do all the addition and subtraction first, from left to righty, and then we do any of the multiplication and division second. And we're not going to really worry too much about exponents and parentheses like we did with the distributive property, which in that situation we did numbers that were outside the parentheses first. And so what we're going to be doing, and you're going to have two operations going on. That's why it's a two-step. So it'll either be add, subtract, or multiply or divide, and we're going to do it in reverse order of operations, and it explains that in the box right here. So I'm going to go down to the samples. You can, of course, read all the examples up here. Just a reminder that the only time you use a closed dot is if it's inclusive, which means it has the equal sign underneath the inequality. And you're going to use an open dot when that equivalent sign is not included. So taking a look, and I just want to refresh your brain, so as you're going through these, you can say, okay, number one, I'm looking at the inequality, which is the less than sign. There's no equal underneath. This will be an open dot. This will be a closed dot. This will be an open dot, and you just kind of get used to it. Okay, the more you practice, the better you get. So we're going to solve number one. It says 3x minus 4 is less than 17, and I want to solve and graph the solution set on the number line. So again, we're going to do all the addition and subtraction first. So I'm going to add 4 to get rid of this minus 4. I'm doing the opposite. I'm going to add 4 to both sides. When I do that, I'm going to leave the inequality alone. Remember, adding and subtracting does not flip-flop your inequality, only multiplying and dividing by negatives, which we're not doing right now. We're adding or subtracting. So these cancel out, and I get 3x is less than, sorry, this keeps auto-focusing, 17 plus the 4, which when I add those, I get 21. That's step one, add or subtract. Step two would be to multiply or divide. Now I notice the 3 is positive, so that's good. That inequality is not going to flip around. Opposite of multiplication is division, so I'm going to divide both sides. And I get x is less than 21 divided by 3, which is 7. So anything less than 7 will work on the inequality. Now I can pick a number like 0, which is really easy to use. It's less than 7. And if I plug it in, 3 times 0 would be 0. Take away 4 would be a negative 4, which would remain less than 17. So sometimes picking a number, check it out. You can check it step and see if it works. So since x is less than 7, this arrow kind of shows me which way it's traveling. I know it's going to be an open circle on 7 and traveling anything less. And so then I've graphed my inequality. Just a reminder, some of you are having a hard time with this. The darkening happens on the line itself, and the open circle goes in the location where I'm not including 7, but anything less than that. Okay, let's take a look at number 2. This is where you have to be careful because it's negative 2 take away x. And I notice that this is a negative attached to the x. I cannot switch the order of this problem unless I keep change, which you can. And I really encourage you to change the subtraction problems to adding the opposite value to make life a lot easier. So that's negative 2 plus a negative x. And then what I can do is I can switch the order of the x, it's a negative x, plus the negative 2, and it allows me to solve the problem a little bit easier. Okay, now I'm taking a look at the problem and I'm saying, all right, what do I get rid of first? I get rid of this -2. Opposite of a -2 is a +2. Now, I know some of you say, but it's plus. Don't just ignore that. I'm getting rid of the -2. I'm going to add a +2. I get 2. 3 plus 2 is 5. Now, a negative x is less than or equal to 5. And I'm going to write that up here because I need a second step, and I just want to talk about and reiterate really carefully. Normally, I would continue this down, but it's running into that problem, is that this is understood to be a -1. I don't want a negative x, I want a +1. So I'm going to divide by a negative on both sides. When I do that, in the minute I do that, automatically in your head say, I've got to switch that sign. When I divide or multiply by a negative, the inequality has to flip around. So 5 divided by -1 would be a -5. Now you can pick, it says x is anything greater than or equal to -5. And again, 0 is bigger than -5. So if I plug in 0 here, it's real easy to work with. -2 plus 0 would just be -2, which of course would remain less than 3. Then that's a true statement. And anything I pick that's greater than -5 or equal to -5 should work. So I'm going to put a closed circle because it's inclusive, meaning I'm including and I'm equal to -5. And I want everything greater. So if you notice the inequality sign's pointing this way, I'm going greater than, anything greater than, and that's the greater than sign. So we read it, x is greater than or equal to -5. Let's take a look at number 3. I don't like how it looks. I'm going to switch it to 2x plus 6. I'm going to put it on the left side. When I do that, the inequality is going to flip around. And it's not because I'm multiplying and dividing by a negative, but simply because I'm switching the pan balance around the other direction. So I'm putting this whole statement on the left, the 12 on the right, and then the inequality stays chomping on the 2x plus 6, which is bigger than 12. That's how that's read. I'm going to subtract 6, I get 2x is greater than, 12 minus 6 is 6, and divide both sides by 2. I get x is anything bigger than 3. Okay, so I'm going to pick something bigger than 3. Let's pick 6. So 2 times 6 is 12, plus 6 is 18, which is bigger than 12. That works. Open circle at 3, and I want anything bigger than that. Now, I did kind of run into my notes there. I'm just going to go underneath. It's fine, as long as it's on the line. Okay. Number 4. Again, all my addition and subtraction first. Opposite of subtracting 3 would be 2. Add 3 to both sides. When I do these cancel out, I get x over 2 is less than or equal to -2 plus a +3, which is simply a +1. To get rid of the divide by 2, I'm going to multiply by 2 over 1, reciprocal. I multiply by 2 over here. I get x is less than or equal to 2, because 2 times 1 is 2. And then again, that's going to be a closed dot and anything less than or equal to that 2 value. And that's number 4. Number 5. I want to have the x minus 2. I want the x on the left. I'm going to switch locations. X minus 2 is less than 7 is how that's read. So my inequality flips around. I'm going to do the opposite and add 2 to both sides. Cancels out. I get x is less than 9. I'll pick something less than 9. 0 again. 0 minus 2 is -2, which 7 would be bigger than -2, so that works. So x is anything less than 9. I'm going to do an open circle and traveling to the left. Less than 9. Last problem over here. I'm going to go ahead and rewrite this one down here just for the sake of room. And originally that was the problem. And again, I want the x on the left, so I'm going to do -x over 3 plus 1. When I do this, again, I have to switch my inequality around, and I'm not doing this because of the negative. I'm doing this because I want the x to be on the left side. So I'm going to subtract 1, subtract 1. 1 take away 1, that leaves me 0. And I get negative x over 3. Okay, understand that to get rid of this negative, I have to multiply by a negative. When I do, I'm going to multiply by a negative 3 over 1 so that I can do a negative times a negative is a positive. The 3's cancel out. The minute I multiply both sides by negatives, this sign has to flip around. So once I've done a negative times a negative, this is going to negate itself and it's going to give me x. My inequality is going to be greater than or equal to, and anything times 0 is 0. So my answer to this is anything bigger than 0. Well, I'm going to pick 3 because 3 divided by 3 is 1. So 3 divided by 3 would be a negative 1 plus a positive 1 would be 0. And 0 would be less than or equal to 1, or 1 is greater than, and that works. So x is bigger than or equal to 0 is a closed dot, and again, it's heading to the right. And you have to be careful on the negatives and when you're multiplying or dividing. That's why the inequality has to switch around. Okay, so that's my solution. This is my solution. This is my solution. And notice I did a check it step in my head. I really want you to get in the habit that if you're not doing it on paper, which you're more than welcome to do that, is that you're checking it in your head, making sure it works, because some of you still aren't doing that. You're missing it, and then you're not going back and fixing it. So the check it step will help to ensure you're doing it correctly. Okay, so these are the notes you're going to glue in. This is the last lesson in 7. Until next time when we start reviewing for the test, we go into chapter 8, 9, and 10 next. All right, y'all take care.